Hi guys, let's start a new chapter. The new chapter is called Reflection. Now, before we get into mathematics, let's revise some reflection that we've learned in physics. We've done this in grade 8, maybe in grade 7 as well. So, reflection in plane mirror. So, if you look at the image on the left, you would see that the girl is standing here in front of the mirror, and her image is being formed behind the mirror of the same height, and it is at the same distance behind the mirror as far as the distance is in front of the mirror, which means in this example AD and DC are equal. So reminding you of two characteristics of image form: it is formed behind the mirror and it is formed at the same distance away as it is in front of the mirror. So if you remember these two characteristics, well, then this chapter is a cakewalk for you. So now that we've revised these two properties, let's look at it from the mathematics perspective on how it works. So this is very fairly involved with the chapter symmetry as well, which we've done in 7th as well as 8th. So let's look at this question. It says, if I imagine let's say let me show a mirror on the x-axis. So imagine that the x-axis is a mirror, which means I am trying to reflect things on a mirror. So imagine x-axis a mirror, which is my red line, and here we know that the equation of the x-axis is y is equal to 0. So in the question, sometimes they'll give it as y is equal to 0, sometimes they'll call it the x-axis. So imagine you have the mirror on the x-axis and you trying to plot the reflection of this point A46. Now, if this is the mirror and this is in front of the mirror, we know that the image will be formed behind the mirror. So in this case, the mirror will be formed in quadrant 4. So let's quickly revise. This is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So behind behind the mirror is quadrant 4, and it is 3 units on the y-axis, as in three boxes ahead on the y-axis. So this will be formed at the same place, but three boxes behind the y-axis. So this would be the reflection of this point on x-axis. Let's call this reflection as a dash, and the coordinates of this point will be 4, -6. So this is a dash, and a is being reflected on the x-axis, and it gets formed behind the mirror, which in this case is in quadrant 4. So if a is 4, 6, then quadrant of a dash, which is reflection on x-axis, is 4, -6. Now, in your book, you would notice that they call it mx, which means subscript x and m. This is basically means that you're reflecting it on the x-axis. Now let's look at the same point if I try and reflect it on the y-axis. So now this blue line that I am drawing now is my y-axis, and this is my mirror. So my mirror is exactly on this axis. You would remember that the equation of this line, which is y-axis, also x is equal to 0. So you might find people calling it x is equal to 0, or some question referring it to as x-axis. That's something that you need to keep in mind. Now if you look at this again, if you are in quadrant 1, the image will be formed behind the mirror, in this case in quadrant 2. This is 2 boxes ahead on this side, so the image will be formed 2 boxes behind on this side. So this would be my image of A, we calling it a double dash, and the coordinates of this point will be -4, 6. Yes, -4, 6. So my a double dash is -4, 6. Perfect. So earlier on the x-axis it went from 1 to 4, on the y-axis it went from 1 to 2, basically behind the image, behind the mirror. Now let's look at if my mirror is passing through the origin, which means I am reflecting it at the origin. So when you're reflecting it at the origin, which means your mirror is kept like this. Your mirror is kept like this. So this is the green line that I have plotted is the mirror. So you kept the mirror like this, and you reflecting it against this mirror. So when you are these many units in front of it, which is, you can calculate this distance using Pythagoras theorem or using distance formula, whichever way you like. But again, this will be formed exactly behind at this point, right? The same distance at the same angle. So this point where this image will be formed would be, let's call it a triple dash, or I'll change the color, but not too visible. This will be a triple dash, and this point is in -4, -6. This is reflecting at origin. So you are keeping your mirror at point O, and the reflection will be formed exactly behind. Right? So these are the three kinds of reflection in this chapter. If you understand this simple concept, then this chapter will be absolutely nothing. So when I reflect 4, 6, then this will become -4, -6. Now, there is something that I would want you to notice now. So this is y-axis. This is known as reflecting on y-axis. So this is written also as my. Now, reflecting it on origin is also written as mo. So if you write mo, it basically means that you're reflecting on the origin. If you write my, you're reflecting it on the y-axis. If you write mx, you're reflecting it on the x-axis. Now let's look at what changes when I reflect it on the x-axis. 4 and 6 remain the same, but the y-coordinate becomes, the sign changes. So instead of positive, it becomes negative. So the coordinates remain, in terms of the magnitude, remains the same, but the sign of y changes. So when you do x reflection, which means when you do mx, sign of y sign changes. So on x, sign of y changes, because you may not need to plot it every time. You would need to know or remember certain trick to remember it. So if you reflect it on x, the sign of y changes, nothing happens to the x coordinate. Let's look at reflecting on y. Again, this was 4, 6. The magnitude remains 4, 6, but on reflecting it on y, the sign of x changes. So then if you're reflecting it on y, x sign changes. So this is an easy way of remembering. If you reflect on x, y sign changes. If you reflect on y, x sign changes. The magnitude of the coordinates remains the same. Now let's look at origin, which is mo. The magnitude again remains the same, like 4 and 6, but the sign of both of them changes, which means if you're doing mo, then both x and y sign change. Perfect. So both x and y sign change. So I repeat, on x-axis, when you reflect, sign of y changes. If you reflect on y, sign of x changes. If you reflect on origin, both signs changes. Both signs change. Now let's look at, if I reflect a dash, which is here 4, -6. If I reflect it on the y-axis, so if I reflect it, which is this point, on the y-axis, what happens? Well, it is two boxes on the fourth coordinate. It will go 2 boxes on the third coordinate, which means this point will become a triple dash, which I am also calling b. So b is equal to a triple dash, and this will be, like we said, the sign of x will change, which means this will become -4, -6. So here I would want you to notice that here I am doing 2 reflections. First, I reflected a to a dash, and then I reflected a dash to a triple dash. Did you notice anything? The a was 4, 6, and after 2 reflections, it became -4, -6, which means both signs changed. Which means I could have done a single reflection of mo, and I would have got the same one. This will become more clearer when we go to the next, when we solve a question, but keep this in mind. And then the last point I want to talk about is an invariant point. Now, invariant in English, what does it mean? Yeah, invariant in English basically means a point which doesn't vary, a point which remains the same. So there are points which are invariant when you reflect it on the x-axis or y-axis or on origin. So let's look at a point, let's say 4, 0. If I reflect this point on the x-axis, where will it go? Well, it will remain here because this point theoretically is on the mirror itself, right? So where will it go? We know that the sign of the y will change, so it will become 4, -0. Well, there is nothing called -0, it remains here. So 4, 0 is an invariant point for x-axis. So invariant point for mx. Now let's look at a point 0, 8. Now if I try and reflect this on y-axis, where will it go? Well, again, it will not go anywhere, because I know when I reflect on y-axis, only the coordinates of x change, or only the sign of x changes. So even after reflection, it will become 0, 8. So this is an invariant point for reflection on my, which means my. And now the last thing, which is the third axis which we looked at, let's look at the origin. Now if I have a point which is 0, 0, and I reflect it on the origin, which is I reflect it on origin, where will it go? Well, it will remain here, which means this is the point which is invariant for reflection on MO. So these are the three invariant points that I've talked about. Are there more invariant points? Yes, any point on the x-axis will be invariant for reflection on x-axis, because it will remain the same. And any point on the y-axis would remain invariant for reflection on y-axis. So that brings me to, are there any more points which will remain invariant when reflected on origin? You think about it, maybe there are, maybe there aren't. So you think about it, I'm not giving you an easy answer. Let's look at the, start the questions now. Let's look at exercise 12A, question number 1. So it says complete the following table, the point is given, transformation is given, and the image is given. So in this one, we don't know the transformation. I notice that 5 becomes -5, which means the value of x coordinate, the sign of the x coordinate has changed. And I notice that the sign of the y coordinate also has changed, which means both signs change, which means this is MO, reflection on y-axis. So reflection on origin, not y-axis, my mistake, reflection on origin. So MO. Next, look at the part 2, 4, 2, when reflected on the x-axis. So when you reflect on the x-axis, the sign of the y coordinate changes, which means this will become 4, -2. Let's look at the third one, reflection in y-axis. So when you reflect in y-axis, which sign changes? Yes, the sign of the x changes. So this is the reflected image, which means y would still have been same, nothing would have changed for y. The sign of x has changed, but in this case x is 0, which means this is an invariant point on reflection on y-axis. Part 4, 6, -6. If I reflect it somewhere, the sign changes. So 6 becomes -6, which means x sign has changed. In fact, y sign has also changed, which means this is MO, which is reflection on origin. Perfect. And then the last one, 4, -8, -4, -8. So 4 changes to -4, which means sign of x has changed, but the sign of y is not changing, which means this is a reflection on y-axis, because when you reflect on y-axis, only the sign of the x coordinate changes. And let's look at question number 3. Question 3 says, state the coordinates of the following points under reflection in x-axis. So when you reflect in x-axis, the sign of y changes. Yes, so sign of y changes, which means 3 and 2 will remain the same, but the sign of y will change. This will become -2. 0, 0. So which means sign of y will change, which is 0. Even if I have -0, it doesn't matter. So this is your answer. Let's look at question number 4. State the coordinates of the following points under reflection in y-axis. So here, since we are reflecting y-axis, the sign of the x will change. Magnitude would remain the same for both of them. So this is positive, which means after reflection it will become negative. Similarly, in part 3, the sign of the x will change. So -8 will become 8, and nothing will happen to our y coordinate. That's about it. Let's look at question number 5, which is reflection in origin. So when you reflect in origin, sign of both x and y coordinate change, which means this will be 2, 4. -2 will become 2, -4 will become 4. And then the second part, third part here, which is 0, 0, sign of both will change, but 0 sign doesn't matter. In any case, I shared with you, this is invariant. So invariant on origin. I hope you also noticed that this was invariant even on x-axis. In fact, this will remain invariant even on reflection in y-axis. Anyway, let's look at question number 6. Question 6 says, state the coordinates of the following points under reflection in the line x is equal to 0. So like I said, x is equal to 0. Which line is this? Yes, x is equal to 0 is basically the y-axis. So now, once you understand that x is equal to 0 is y-axis, we can go ahead and do this. So when you reflect on y-axis, the sign of the x coordinate will change, which means negative 6 will become 6. Nothing happens to 4. The next one, which is 0, 5. Now 0, 5, the sign of the x will change. 0 remains 0. This is 5. So again, this is invariant on reflection in y-axis. Question number 7 says coordinate of the point reflection in y is equal to 0. Now y is equal to 0 is basically the x-axis. So when I reflect in the x-axis, the sign of y changes, which means negative 3, 0. 0 becomes negative 0, which in any case is 0. So this is invariant for x-axis. The next one, negative 3, negative 1, negative 3, the sign of y changes, which means negative 1 remains negative 1, but negative 3 changes to 3. So here, now before we move on, I want to talk about a couple of things, which is mx. Let's look at a point mx of 3, 2. So this is when I do mx of 3, 2, this would become, the y will change, this will become 3, negative 2. Right? So this is the first transformation that I did, and let me do my now. Let me do my of this. So when I do my, the sign of x changes, which means this becomes negative 3 and this remains negative 2. Now I have done, this is my second transformation. If I had to do only one transformation, what would that mean? So mx followed by my, what does it give me? If I have to change 3, 2 to negative 3, 2, which means if I have to change both the signs, what will I have to do? Yes, I will have to do mo, which means reflection in origin, which basically means mx followed by my will give me an mo. You should remember this, right? Let's do one more. Let's look at the same thing, but this time in another format. Let me look at 3, 2, and now let me do my first. So when I do my, what will happen? This is my first transformation. The x coordinate will change, which means this will become negative 3, 2. And next, let me do the second transformation. Let me do mo. So when I do mo, sign of both x and y will change, which means this will become 3 and this will become negative 2. Now in case I have to do a single transformation, right? So this single transformation changing 3, 2 to 3, negative 2, which means x sign is not changing, only the sign of y is changing. When does it happen? Yes, when I do mx, which means reflection in x-axis, which means my followed by mo will give me mx. What I seem to notice is that whichever two you do, the third one will be the remaining one, which means mx dot my will give me mo, my dot mo will give me mx, my dot mx will give me mo, or mo dot mx will give me my, which means whichever two you do, the third one will be the answer, a single transformation. We'll do some more questions, it'll become even more clearer. So let's look at the next question. The next question we do is question number 8. A point P is reflected in the x-axis. Coordinates of its image are negative 4, 5. Find the coordinates of P. So P, let P be, let's say A, B, and this is part 2, sorry. Let P be AB, and we are doing reflection on x-axis. When I do reflection on x-axis, what do I get? My coordinates of the y variable change, which means this becomes A, negative B. Now in this question, A, negative B is given as negative 4, 5. Therefore, A is equal to negative 4, negative B is equal to 5, which means B is equal to negative 5. Therefore, point P is AB, which in this case is negative 4, negative 5. Let's check if this answer is correct. -4 comma -5. If I do mx, coordinates of y will change, which means this will become 5. Perfect. So my p is equal to -4 comma -5. Let's look at part 2. It says what will happen if part 2 is find the coordinates of the image of p under reflection in my. So p is basically -4 -5. If I do my to it, basically what I am doing is changing the coordinates of changing the sign of the x coordinate, which means this will become 4 comma -5. Perfect. Let's look at question number 9. Question 9 says point is reflected in origin and the coordinates of the image are -2, 7. Again, let p be equal to ab. When I do mo, what I get is p with -a comma -b, because the sign, let's call this p dash. You should give it a separate name. If this is p, this is p dash. In fact, yeah, so you should never use the same coordinate. If this is p, then the reflection can be p dash. So p dash is -a -b, which is given equal to -2 comma 7, which means -a is equal to -2 and -b is equal to 7. Therefore a is equal to 2 and b is equal to -7. So p is equal to 2 comma -7, which is what I write as the answer, 2 comma -7. Part 2. What happens if I do transformation on the x-axis to 2 comma -7? So when I do reflection on x-axis, my sign of y coordinate changes, which means 2 comma 7. Let's look at next question, which is question number 11. Question 11 says the point pxy is first reflected in the x-axis. So if it's reflected in the x-axis, what will happen? The coordinates of the y would change, which means this will become x comma -y. And then reflected in the origin to give you p dash. So when you do reflection in origin, what do you get? You change the sign of both of them, which means this will become -x comma y. And -x comma y is given equal to be -8 comma 5. So -x is equal to -8 and y is equal to 5, which means x is equal to 8. Therefore p is equal to 8 comma 5. Now let's notice I have 8 comma 5 on which I did my first transformation of mx, and then I did my second transformation of mo, and what I got was -8 comma 5. If I had to do one single transformation, all I am changing is the sign of the x coordinate, which means I am doing my. This is what I had told you. If you take any of the two variables, any of these two reflections, the resultant in one reflection would be the third one. mx.mo is equal to my. Let's look at the next question. The next question that we do is question number 13. So let's look at question number 13. The point A 4 6 is first reflected in the origin to point A dash. So if you're reflecting it in origin, well, the sign of both the coordinates will change, which means this will become -4 and this would become -6. Then A dash is then reflected in the y-axis to A double dash. So when you reflect in y-axis, the sign of the x coordinate changes, which means this becomes 4 comma -6. Write down the coordinates of A double dash. So A double dash will be 4 comma -6. And then they are asking what is the single transformation from A to A double dash. So again, like I said, first I'm doing mo followed by my. This should, in my opinion, should be mx. I've told you mo.my will be mx. Any two transformations you take in simultaneously, one after the other, the third, it will be resultant, will be the single transformation of the third one, which is whatever is remaining. So in this case, let's see, if I have 4 6 and I want to change it to 4 -6, the sign of only the y coordinate is changing, which means I am doing mx, which means reflection in x axis. Perfect. Let's look at the next question. The next question that we do is question number 16. So let's look at question number 16. Question 16 says, on a graph paper, plot the triangle ABC. So let's try and plot the triangle ABC. A is 3, 1. So this is 3, this is 1. I have plotted A, this is 3, 1. Next is B, which is 5, 0. This point is B, which is 5, 0. Next is, this is B. Next is C, which is 7, 4. So this is 7, 4. This is my C, 7, 4. So on a graph paper, plot the triangle, which means I'll have to make the triangle. You will join them using a scale. I've shared this with you earlier. I do not. Oh, I have access to a scale on this one. Sorry, my mistake. Let me just change this. I can join them using a scale. This is not that software that I was using earlier. Right, 1 second. Let me change the thickness of this line. So this is the first one. Then let me join A with B, and eventually let me join A with B with C. So this is the triangle that I have. Next, let's look at what do they want. Then they say, on the same diagram, draw the image of the triangle ABC under reflection in the origin. So when I reflect into the origin, what will change? The sign of both the coordinates will change, which means A dash will become -3, -1, B dash will become -5, 0, and C dash will be -C, -4. So let's change color and let's see what will -3, -1 look like. This is -3, -1. For me, this is A dash. B dash is -5, 0, which means this is B dash. This is -5, 0. A dash is -3, -1. And then the last one is -7, -4. That's -7. This is -4. This is C dash, -7, -4. And again, I would need to join them using a straight line. So I'll take a scale and I'll join BC, then I'll join AB, and eventually I join AC. Not AC, A dash, C dash. So this is the reflection of this triangle. So triangle A dash, B dash, C dash is equal to so this is this triangle and this is triangle ABC. Perfect. Done. Let's look at the next question. The next question that we do is question number 17. Question 17 says a point 4, -1 is reflected as A dash in the y-axis. So when you reflect it in the y-axis, only the sign of the x coordinate changes, which means it becomes -4, -1. Next, B on reflection in the x-axis is mapped as -2, 5. So we need to figure out what B is. B, when you're reflecting on x-axis, only the coordinate of the y sign of the y coordinate changes, which means x remains the same, and this would have been -5, which means on reflection the coordinate of -5 has changed to -5. So I need to write the coordinates of A dash. So A dash is basically -4, -1, and B basically is -2, -5. I hope you figured out that this chapter is way too simple and extremely scoring. You will definitely get one question from this, sometimes a 3-mark, sometimes a 4-mark, sometimes a 5-mark question, and extremely simple. Let's look at the last question from this exercise, question 18. It's slightly a very interesting question. You can put a star on this question. The point -5, 0 on reflection in a line is mapped as M0. Oh, so where are they reflecting? They are not sharing with us, but they are saying -5, 0 becomes 5, 0. So let's look at where could it have been reflected. The coordinate of the sign of the x has changed, which means it could have been My. But has the sign of y coordinate also changed? We can't figure out, because 0 would remain 0 under any reflection. So this is My, or this could even be Mo, which means the sign of both of them have changed, but we are not able to realize. So the single transformation is either My or Mo. We don't know. Next, and the point -2, -6 on reflection in the same line. So we are reflecting it on the same line. Is given as 2 negative 6. So now this is not an invariant point, so it will help us identify. The sign of x has changed, which means this could be my, but the sign of y has not changed, which means this cannot be mo and this cannot be mx. So this is my. So since these two are the same, what is the line of reflection? This is reflection in y axis. Since they are giving the line, it is ideal that you write the line directly, not write it as my or mx. You should also read the question carefully, because there are some questions where they say write the line of reflection and also the equation. So in case they had asked you equation of y is equal to 0, equation of not y is equal to 0, equation of y axis, the equation of y axis is basically x is equal to 0. So here when I looked at the first transformation, I had two possible options, but when I looked at the second point, I realized MO is not possible, which means it is MY, which is reflection in Y axis, or X is equal to 0. Next is write the coordinates of the image of 5, negative 8 in the line obtained in first part. So this we are reflecting in MY, which is reflection in Y axis, which means coordinate of the X will change, which means this will become negative 5 and negative 8 will remain negative 8. That brings me to an end of this exercise. Some questions as homework. Question 3 part 2, question 4 part 2, question 5 part 2, question 6 part 3. These are extremely simple questions, will not even take you less than a minute to solve all of them. 7, then question 10, question 12, question 14, question 15. That's about it. Thank you so much. Take care. Be safe. I'll see you with the next video. Bye-bye.